Hello, everybody. I would say happy Tuesday or happy Wednesday or happy Thursday, but I'm not even sure when I'm going to be publishing this. I will say that I am recording it on May the 4th. So even though it is in the past, I'm going to wish you all a happy Star Wars Day. Um, I know that as I record this on Monday afternoon, I'm planning on watching at least something Star Wars related. My son and I watched the last episode of the new Clone Wars on Friday, and I hear that episode 9 is up on Disney Plus now, so maybe I'll check that out for the third time, but we'll have to see. Maybe I'll see what the kids are in the mood for. But in any case, you came here not to talk about Star Wars, but to learn more about volumes of solids of revolution. So I have chosen not a few, I've chosen a couple questions from past AP tests. And just as a matter of perspective, as I pulled up the last few years, I think I pulled up 4 different tests, and 2 of them had solids of revolution clearly that I could see as I skimmed through the questions. Um, One thing that I noticed about both of these questions is that the axis is right up against the region. So even though the formula is pi times the outside radius squared minus pi times the inside radius squared, um, both of these questions just had pi r squared because the inside radius was 0. But something to keep in mind, it is certainly possible that you'd see something with an inside and an outside radius, but I also say it's probably fairly likely that if you see solids of revolution, it would just be a single radius. And each of those is also just a part of these problems. Of the 2 questions I looked at, the volume part was um, basically 4 points on the one we're going to take a look at first, and then the volume was 3 points on the one that we'll do next. And so it's not like you're going to have a solids of revolution question that's going to determine 40% of your grade. It's just going to be a smaller part, but of course, part that you'd like to get. So let's take a look at question number 3. I'm refreshing my memory. We're looking at write but do not evaluate. That's a key. I don't need to get a number, especially when this would be, let's see, this would have been a non-calculator question, I believe. 2011. You know, I'm honestly not even sure if this would be calculator or no calculator. I'm going to treat it as a non-calculator question because I didn't use one when I did the problem. But part A says an expression for an integral that gives the perimeter of the region that we're looking at, which, by the way, if you're not looking at question 3, pull up a PDF or open it up on Schoology so you can see what region is being referred to in case it's been a while since you looked at this problem. And so perimeter, 3 of the sides of this shape are just line segments. So that was easy. And then the rest of it was a length of an arc. So I'm using the arc length formula. I've got that shown here. Nice thing to have easily accessible as you're taking the actual test, but it's the integral of the square root of 1 plus the derivative of the function squared. And so I took the derivative of the function and I plugged it in as f prime. The 3 side lengths, just looking at the graph and figuring out what those lengths were, I've got 1 as the height, k is the width along the bottom, and then e to the 2k is the second height over on the right side, and then this integral. And that's it. I might be tempted to try to simplify this or do some evaluation, but it's not going to be worth any points. So that's all we're looking at there, the expression for the integral. Part B, here's our volume part. So the formula, pi times the integral of the radius squared, where in this case the radius is just the distance from the axis, which is the x-axis, to the function, and so that is just e to the 2x. And so pi times the integral from 0 to k of e to the 2x squared. And I do need to evaluate this one, at least as much as I can, until I get to that k. And so I simplified a little bit, got into a form where I could anti-differentiate, and then plugged in my values. Worth noting, e to the 0 is not equal to 0, so you can't just ignore it like you do maybe for some polynomials. We end up with this, and this would get full credit, but since there was a pi over 4 or 1/4 that I could factor out, I factored out that 1/4 to make it pi over 4. And so that is my answer for part B. I mentioned that part A was, I didn't mention, part A was worth 3 points, 1 point for the derivative, 1 point for the integral, and 1 point for the answer. Part B is 4 points, 1 point for this integrand, 1 point for recognizing that we're going from 0 to k, 1 point for the antiderivative, so I guess getting to this point, and then of course 1 point for the answer. Part C, they snuck in a related rates question. We've got volume. The answer that we got on part B, our volume, was this, pi over 4 times e to the 4k minus 1. And they said find, let's see, dv dt when k is equal to 1/2, and dk dt is 1/3. So as soon as I see these dv dt's and dk dt's, I'm thinking about related rates. So I take my equation that's got v in terms of k, and I take the derivative in terms of time. So dv dt, and then the derivative of this stuff, well, the 1 just goes away. So we end up with pi over 4 times the derivative of e to the 4k, which simplifies a little bit, but don't forget about tacking on that dk dt. I've taken the derivative of something in terms of t, and k isn't a constant, which bugs me a little bit. They are letting k be a variable that is changing with time, but we'll go with it. dk dt, and then we plug everything in. We know that k is 1/2 and dk dt is 1/3, and so when I plug those in, I get pi e squared over 3. I'm getting 1 point for writing down dk dt, and that's they said 1 point for applying the chain rule, and then 1 point for the answer of pi times e squared over 3. And I'm looking at the scoring rubric, and they called it pi e squared times 1/3. If you call it 1/3 pi e squared, you're getting credit for that. The second question was more recent. It was from 2016, question number 5. And so this is definitely a non-calculator question. I think the other one must have been also, but I could be wrong. Either way, this one I'm doing without a calculator. And I found myself, I noticed after I got done with this problem, on every single part of this, I wrote down something that they told me. This is what R is, this is what R is, this is what R is. I'm not sure why I did that, but it felt like part of a good explanation as I went through. Part A says find the average value of the radius. Average value formula, 1 over b minus a times the integral from a to b of the function. And so I'm just plugging it in. They're going from 0 to 10. So the width of my interval is 10, 1/10 of the integral from 0 to 10. I pulled that 1/20th outside of the integral to give myself an easier antiderivative. I maybe showed more work than I would need to show for this one. Dealt with a little bit of simplification of fractions. I was hoping to see some stuff simplify more easily, but this is what I came up with, 109 over 60. I wrote the units down. You don't have to do it unless they ask for it. And if they ask for it, you definitely have to do it. If they say using correct units, or state the units, or state the dimensions or whatever, make sure you absolutely do that. They didn't here, so I don't think I lose a point if I leave it off, but why not? If you know what you're looking at. I've got the average of something that's in inches, so it is in inches. I got 1 point for the integral on this one, 1 point for the antiderivative. So I guess this step going from the integral to the antiderivative, and then 1 point for the answer of 109 over 60. Part B, here is our volume. Find the volume of the funnel. So pi times the radius squared. I'm integrating from 0 to 10. Now I'm integrating in terms of h, which we're thinking of similar to y. If you're used to functions, y is a function of x, but here we've got the radius as a function of h. And so as we go higher in the funnel, the radius is getting bigger. Lower in the funnel, the radius gets smaller, which, by the way, is, as I'm saying that, I'm thinking ahead to part C, where we had to do a little bit of related rates, but I'm getting ahead of myself. Pi times the integral of the radius squared. The radius is the function that we were given, so I plugged that in. I squared everything out and took that 1/20th squared, 1/400th, and pulled that outside of the integral so I didn't have to deal with it. Don't try to integrate it as is. FOIL that thing out to give yourself a nice, easy antiderivative. And I call it nice and easy, even though I goofed it up and called it h to the 5th over 4 the first time I did it. But I caught my mistake before I made it to the end of the problem. And so here again, I'm not sure, I maybe wrote down more steps than I would need to write down for something like this, but evaluating, plugging in everything, I ended up with 2209 pi over 40 cubic inches. And if you're really scrapped for time next week on the AP test, you're scrambling and you know that the deadline for submission is coming up on you. If you can get to, I would say, this point, you should get credit for that answer. It has always been the policy of the AP test that simplification is never worth points. If you have time, then absolutely go ahead and do any simplification. But um, I think anything else that I did here, this whole last line is probably superfluous. Part C, the function contains instant with the height. Okay, so when h equals 3, the radius is decreasing at a rate of 1/5. So I've got my radius equation, and I guess I wrote it down here because I wanted to see what I was taking the derivative of, dr dt, and then the derivative of this stuff is just 1/20th times the derivative of this, and then here again, dh dt, don't forget about that. I'm actually getting 2 points on this one for doing the chain rule, so just writing dh dt, I think maybe earned me a whole 2 points. And then plug in what you know. The radius is decreasing, which means that dr dt is negative, and then plug in at time where h is equal to 3, and then just a little bit of algebra to simplify or to solve this and get negative 2/3. Again, I wrote down inches per second because I knew that's what it was. But I believe this is probably the point where you've gone as far as you would need to go to get the full credit. As I'm looking ahead to my planning and trying to figure out what else to do with you guys, I've heard a couple different things. I think some techniques of integration. I'll probably try to find an AP test that uses partial fractions, find another question that uses integration by parts or something like that. But just like this set of questions, it's not just going to be about that. It'll just be, here's a free response question, and there will be something embedded within that question that we want to take a look at. If there are any other things that you guys want to take a look at, certainly let me know. Also, thank you to those of you who sent your well wishes on Star Wars Day. I genuinely appreciated waking up to that stuff. And I guess I'll wrap it up. Hopefully, you're having a great day. Hopefully, you continue to have a great day. And I will talk to you later. Oh, my son says, wiggity whack. Bye bye.